Good morning, everyone, and welcome to IGTV. My name is Joe Kincannon, and with us this morning is Mark Capers. And Mark is going to be talking to us about Stuxnet and APTs driving IT security into non-IT realms. Mark, take it away after choking there. Hope you have a good outing here.
Thanks. Good morning, everybody. This morning I thought I'd talk about how Stuxnet and a couple of other demonstrations that were inspired by Stuxnet kind of represent some real game changers in pushing information security into areas that are traditionally almost non-IT. What we're seeing is that devices that have programmable interfaces are now at risk of being hacked. And they don't necessarily have to be attached to a network. They don't necessarily have to be managed by computers. And bad actors can do some pretty nasty things with them. So going into Stuxnet was a real, the cliche is paradigm shift, but it really was a new proof of concept that demonstrated a whole bunch of capabilities. Granted, this was probably, involved many actors and state sponsorship, but the fact that it can be done means that as time goes on, the sophistication and level of technological savvy is going to be reduced into making these things. So dissecting Stuxnet for a minute, it was a purpose-built attack that targeted a specific set of technologies. There were three levels of what Stuxnet looked for. And it went after the programmable logic controllers, PCLs, which are manufacturing machine controllers that were managed by a set of Siemens management software that sits on Windows on a closed network. And to do this, basically, the virus had to be able to do cross-Windows infection, which was done like using a configure-like capability. Once it got onto the system itself, it then infected the industrial software that Siemens had written to manage the PCLs, PCS7, WinCC, and Step 7. The virus then looked for specific things within the PCL configuration. Specifically, in this case, it looked for a Vacon or Ferraro vibration controller that was configured on a Siemens S7 PCL. And what would happen then is when it found those things, it would install malware into the PLC itself, so that the actual PLC would then have a bit of code running in its memory, and it would intercept calls to the messaging bus of the PLC, and then it would report back different settings than the ones that were intended. So when certain criteria were met, it would modify. What it would actually ended up doing is it modified the vibration frequency of the centrifuges and knocked them out of performance spec, and basically it was industrial sabotage. The fact that it installed a rootkit on the PCL unit itself was the first documented case on this particular platform. It hid the malware on the system, and it masked the changes of the systems that were being monitored. So people back in the control room said, this thing's spinning at, 75, hertz, and it's spinning at 95 or 5. So the fallout from this is people started to look at PLC controllers and SCADA systems and said, okay, well, they did it with the Iran nuclear program. What else could we do with this stuff? The first example I'll cite, Joe brought up on the conference call the other week. And basically, this was a SCADA and PLC vulnerability in correctional facilities. Most jails and very large correctional facilities use PLCs and SCADA to control the gates, the doors, monitoring systems for the jail itself. And apparently, what had happened is on a Christmas Eve, not terribly long ago, all the cells on this death row block opened seemingly at random. The warden then basically asked security experts to investigate. The resulting white paper, basically demonstrated that there are significant vulnerabilities in those PLCs used at the correctional facilities, and people, because of the ubiquitous of the network and the fact that they weren't properly cordoned off, people could get in and flip the switch to open locked doors or locked closed doors on cell doors and gates. The second example was in the news, and it basically came out of a Black Hat conference seminar. Jerome Radcliffe, who was a diabetic and a security researcher, basically looked at Stuxnet and said, hey, I have an insulin pump and a glucose monitor. Can I hack it? The combination of the insulin pump and the glucose monitor, which used a wireless USB for communications, basically, as he puts it, turned him into a human SCADA system. So his presentation was called Hacking Medical Devices for Fun and Insulin, Breaking Human SCADA System. It was at Black Hat 2011 this year in Vegas. He managed to intercept the wireless control signals, reverse them, inject fake data, and then send it back to the pump. What this demonstrates is that he can change the amount of insulin injected by the pump, either reducing it or increasing it, and in both cases was able to show that the pump showed no sign of being tampered with, and it generated no warnings. So if somebody wanted to kill somebody who was a diabetic, they could tell them, shut the pump off or turn it full blast, and they would very likely be able to kill that person without any trace, which is kind of very scary. So why is this a game changer? All three examples demonstrated that any configurable technology that is managed by a control system with a common IT communications or interface bus can be at risk. It's important to note that the targeted endpoint doesn't necessarily need to be a PC or a computer in the conventional sense. It generally requires some type of processing unit with a memory configuration. And as well, it doesn't necessarily have to be directly connected to the internet. With the insulin pump scenario, that was a wireless USB, and Stuxnet actually was spread via USB stick on what was supposed to be an air-gapped, secure network. So as we deal with all of this things now that as IT security professionals, we're used to dealing with servers and workstations and in some cases some printers. Now we have all sorts of things out in our infrastructure that may or may not be connected to our network, but because they have a programmable interface and use common buses that we would normally associate with IT, they might actually be at risk. So in order to provide service to your clients and your stakeholders, have a plan in place to be able to assess non-IT or SCADA type things as an IT asset. Make sure that your policies can address the authentication and access control you need to do this. So what needs to be assessed? If it has a changeable configuration or have parameters that can be monitored, it can probably be hacked. I mean, I've even seen hacks for Big Mouth Billy the Talking Bass Toy. So, if it's got firmware and it's got something that you can program at all, chances are it can be hacked. So look for things that are, not classically IT networked, but they might use USB, Bluetooth, Wi-Fi, or may have some token connection to your org's IT network for internet access. Again, most of this is going to surround SCADA, which is the supervisory control and data acquisition systems. So if you're in manufacturing, you have a lab environment, you need to be looking at this stuff. If you have highly automated or controlled facilities and building systems, environmental controls, HVAC, fire detection suppression, automatic door access control, CCTV, things of that nature, that's probably where you're going to need to be prepared to help. So put together a framework, an assessment template in place for dealing with this. And remember, you want to be a hero to your stakeholders. So light a candle rather than curse the darkness, and be proactive and try to get ahead of the hype. Because as Joe mentioned, the Vanity Fair article is very scary. And you want to make sure that you're leading the curve so that when your leaders come to you, you have answers for when they say, well, what about this? Can it affect us? You can say, well, we haven't totally looked at it, but let's get out and do a survey and see if anybody has this stuff and what it might mean. So the key to most of this stuff is going to be defense in depth. People and process will be major drivers of the success in countering these types of targeted attacks within your infrastructure. You need to assess the risks. So, for a given system, if you've never seen it before and it's off your IT radar, you need to ask, what does the system do? What are the, CIAs of the system? What are the confidentiality, integrity, and availability requirements? Typically, with SCADA, you're looking at integrity and availability are your key drivers more so than confidentiality. You have to be able to assure that what you're monitoring is what it is, and it has to be available for the manufacturing plant or the doors to open or whatever to function. So you need to develop the scenarios about what would take place if any of the legs of the CIA were controlled or altered by a malicious actor. Understand that with some of these systems, they have severe technical limitations. Again, they're intended to be a piece of automation that's not classically IT. So you're going to have to probably compensate for, a lack of, authentication, user ID, and the normal things that we associate with, even, computers these days have good access control lists and things like that. If you have a door controller, it may not have any of those things around its function. So you may have to compensate by using physical access controls and physical monitoring, frequent physical inspection, and other process compensators. Likewise, having a means by which to audit the individual system element, you're going to need to develop mechanisms to validate the configuration of the systems. So you leverage, MD5 hashing techniques, other hash mechanisms. Make sure you have good change control, gold disking. Make sure you archive known good and backup configurations and test. Make sure that the people deploying and operating these systems have a means to test, back out, and restore configurations fairly rapidly as you can. So again, that's going to be an emphasis on strong change control processes. So you need to understand how to use your network segregation, your isolation to the degree it makes sense, and make sure that any changes to these systems are done in a very controlled and monitored manner. If something uses a USB or non-secure, non-authenticated mechanism to, update the device, you need to physically secure those interfaces that do the updating and make sure your process ensures that you check the media, you use only approved and authenticated media to do the upgrades. Ensure you're capable of being able to wipe any piece of equipment and install from a known good source. And work with the vendors. The vendors are happy to improve their products because they know if they don't meet your requirements, you're going to be shopping for a new widget come the next budget. So work with the vendors to develop a compensating process and controls and provide them with feedback on where they're doing good and where they're doing bad. And they will more often than not work with you. Siemens has been very proactive in getting its arms around Stuxnet and how to remove it, et cetera. But unfortunately, the genie's out of the bottle, so we're kind of living in a new layer of IT security. So that's basically Stuxnet and APTs driving all of these things into places we never thought they'd go. Joe, back to you.